Here it is given that a bus starts from terminus A and terminates its journey at K. There are 9 intermediate stops between A and K, and these are namely B to J, and the given bar chart shows the distance between some pairs of bus stops, like the distance between A and B is 2 kilometer, and that of between E and F is 1.7 kilometers. So using this arrangement we can find distance between any two stations, and it is also given that the details related to fare which determine on the basis of distance or the number of intermediate bus stops excluding the boarding stop and destination stop is given in the table below. It means if a person travels any distance between 0 to 3 kilometer, the fare that comes out computing on the basis of distance is 3 kilometer, and if a person travels a stretch which includes the number of intermediate bus stops from 0 to 2, that person has to pay a fare of 3 rupees on the basis of fare computed on the intermediate bus stops. And it is also known that in case of a round trip, a person can travel from A to K and then from K to A without terminating his journey at K. At this stage, K will be considered only as an intermediate bus stop. So in case a person wants to travel from A to K and then wants to come back to A from K, then he does not need to get down from the bus at K. In that case, just K will be considered as an intermediate bus stop. Now let's come to fare policy. Fare policy says that the fare increases according to increasing distance or increasing number of bus stops, whichever increases the fare by a larger amount. The meaning of this statement: if I travel a particular distance and compute my fare based on distance as well as the number of intermediate bus stops for my journey, then I'll have to pay that fare which comes out to be the larger one. For example, if the distance covered by traveling two bus stops is 5 km, then fare charge will be according to the distance, that is rupees 5. Here a person is traveling a distance which includes two bus stops and a distance of 5 km. To travel a distance which includes two bus stops, we need to pay rupees 3 as per the number of intermediate bus stop policy, and for traveling a distance of 5 km we have to pay at least rupees 5. In that case 5 versus the fare computed based on the distance travel is the maximum. So for this journey we have to pay rupees 5, not 3. And on other hand, if for traveling 2 km the number of bus stops covered is 5, then the fare will be charged according to the number of bus stops. By having a look at the two given tables, we can say that for traveling a distance of 2 km, if it includes 5 intermediate bus stops, the fare based on number of intermediate bus stops would be rupees 5, and that based on the distance would be rupees 3. So we have to pay rupees 5, which is based on the number of intermediate bus stops. However, from the table it is clear that there is no stretch of 2 km where we need to pay where we would encounter 5 intermediate bus stops. So but this is the case that we have to consider while computing the fare for a given stretch of journey. And further, it is given that anyone buying a ticket of any denomination makes full utilization of that ticket and gets down at the point beyond which the ticket would not be valid or bus reaches its terminus. It means if I buy a ticket, I'll travel as much distance as I can by using that ticket, unless I reach a station and I could not reach to next station by the leftover amount of my ticket. In addition to the given information above, a person trying to minimize and maximize the fare paid can change any number of buses. It means we can get down wherever we want, irrespective of a terminus station or the value of ticket. Let's move to the first question of this set. It is asking what is the minimum possible fare in which one can reach from K to A. We want to reach from K to A, and it can also be noted from the first table that the proportionate fare for a distance in between 4 and 7 kilometer is the minimum. As to travel 7 up to a distance of 7 kilometer, we just need to pay rupees 5. On the basis of this observation, we can say that in order to minimize the fare for traveling a stretch of distance, we should buy a ticket of rupees 5 and sell would try to exploit it to the hilt. So from table it can be noted that the distance between A to F is 6.8 kilometer. It means by buying a ticket of rupees 5, one can travel this much of a distance, and point F onward, if we consider the remaining distance, it is more than 5. So we cannot travel the remaining distance just by paying rupees 5. But from F to J, the distance between F to J is 5.9, that we can travel by using a ticket of rupees 5. And to cover the remaining distance, which is 2.4 km from J to K, we have to buy a ticket of rupees 3. So this is the minimum amount that one has to pay to travel from A to K, though the path that we discussed are stretches that we discussed A to F, and then F to J, and finally J to K, need not to be the only arrangement of different stretches. We can take some other stretches and still we can reach to this figure. Like we can go to some A to D, and then from D to I, and then finally from I to K, and still our fare would remain rupees 13. So rupees 13 is the minimum fare that one has to pay for traveling from A to K. So option C is the correct answer. Let's move to the next question. Here it is given that a person has rupees 5 with him, and it is asking what can be the maximum possible number of intermediate bus stops and the minimum possible number of intermediate bus stops respectively that he can pass through while traveling from A to K. By having a look at the chart, we can say that if a person wants to maximize the number of intermediate bus stops that he wants to pass through or cover while making a journey that can be made by paying rupees 5, it becomes clear that one needs to travel from A to F, as the distances between intermediate stations in this stretch is quite lower than the other stretches, and to cover this journey we need to pay 5 only, and there are four intermediate stations between A and F. These are B, C, D and E. So this is the maximum number of intermediate bus stops that one can pass through by buying a ticket of rupees 5, and there is no such other stresses in the given figure. Apart from B to G, C to S, D to I, and except a few more, where we can travel these many intermediate stops by making payment of rupees 5. So the maximum number of bus stop that one can pass through by spending rupees 5 is 4. Now let's check what would be the minimum number of stops that one can travel after spending rupees 5. For that we have to consider that stretch of two stations wherein the distances between intermediate stops is bit higher on side, and by observations we can say that S to K, the distance between these two stations is 5.4. To travel this much of distance we have to buy a ticket of rupees 5, and the intermediate stations between these two stations is 2. So the 2 is the minimum number of bus stops that one would pass through in case he buys a ticket of rupees 5. So the maximum number of stops that one can pass through is 4, and the minimum number of stops that one can pass through is 2. Therefore option D is the correct answer. Let's move to the next question. Here it is given that government offers a scheme on the 67th Independence Day in which a person can take a round trip from A to K and then from K to A without terminating at K with a single ticket costing rupees 16. It means a person can travel from A to K and return to A just by paying rupees 30 as per the scheme on the 67th Independence Day. And then what is the difference between the maximum possible fare paid with at least one intermediate stop for each sub journey to the minimum possible fare paid for the round trip? Note, while traveling from A to K, AF is an example of sub journey. One thing is important that we need to note here is this scheme is valid only if a person travels from A to K and comes back to A without terminating his journey at any intermediate stops. So we can maximize or minimize our fare still between any stretch of journey. Here it is asking to maximize the fare between A to K and K to A, that is a round trip for this stretch. the fare, it can be noted that a person can travel a distance above 12 kilometers just by paying rupees 16 in case he does not get down to intermediate stations. And it can also be noted that in case we want to maximize the fare that one has to pay to make a round trip, we should buy as many tickets of rupees 3 as possible, because in case of 5 our fare would come down, and if we go for other options our fare would not get maximized. So let's see how many stretches we have to have in order to travel by buying only 3 rupees tickets. First case, A to C, because we have to maximize our travel distance by using a particular ticket. So in case we buy a 3 rupees ticket, the distance that we can travel is 4 kilometer, and in that case we can travel from A to C only, because if we want to go to D then distance would be more than 4 kilometer, this is not possible. So by paying rupees 3, the minimum distance that one can travel is distance 2.9. So A to C rupees 3, and then C to E again rupees 3, and similarly E to Z rupees 3, G to I rupees 3, I to K rupees 3, and we need to repeat the same while return journey. So the total fare that one has to pay in this case will be 15 plus 15, which is the maximum possible fare that one can pay for making a round trip journey. So the required difference in this case will be a 30, which is the maximum possible fare that one can pay for making a round trip, and minus the minimum fare, which is rupees 16. So the required difference is rupees 14. Option C is the correct answer. Let's move to the last question of this step. In this problem, it is given that due to some construction work, route between Z and S is closed. It means no one can travel from G to S directly, or as per the given scheme of thing. Thus, buses reaches H from G via route G, H and OH. The distance in kilometer between different bus stops in the new route is shown in the graph given below, which means now in order to travel from G to H we have to follow the given route, which is G, H and OH. The distance between M and N is given as 2.8 kilometer, and that of O and H 0.7 kilometer. Now it is asking what is the ratio of minimum possible fare to travel from B to I previously to the maximum possible fare to travel from C to Z now, with at least one intermediate stop for each sub journey while traveling from C to Z. Note, while traveling from A to K, A and F is an example of sub journey. So let's first compute the minimum fare that we need to pay in order to travel from B to E as per the previous scheme of thing. On observation, we get the distance between B to I is more than 7 kilometers. So the minimum fare that we have got to pay to travel this distance is 8, as we have to either buy a ticket of 5 rupees and the second ticket of 3 rupees, or we can go for option in reverse order, that is 3 rupees ticket and then 5 rupees ticket. And this can also be noted, the distance is not more than 10, so we can take option of travel taking a ticket of rupees 8 to travel this distance. So the minimum amount that one has to pay for traveling from B to I is rupees 8. B to I is rupees 8. And now we have to find the maximum possible fare that one has to pay to travel from C to J. As we did in the previous question, and it was, in order to maximize fare we need to buy as many tickets of rupees 3 as possible. In that case, first ticket that we need to buy is CE. It would cost us rupees 3. E G again rupees 3, and we can also check whether there are at least one intermediate stop for each sub journey while traveling from C to G or not. It is because there is a intermediate stop D between C and E and F between E and G. So let's move to next sub journey, G to N. The distance between these two stations is 4 kilometers that we can travel by buying a ticket of rupees 3, and then N to H, which is 2.8, that we can again travel by buying a ticket of rupees 3, and then finally S to J, that we can again travel by buying a ticket of rupees 3. So this is the maximum amount that one has to pay in order to travel from C to J now as per the given route. So the required ratio will be rupees 8 to that of 15, which is option A.